Welcome to the video. In this video, we are discussing about the topic of eccentricity. Here the eccentricity is related to the conic section, and in the previous video we have discussed about the different shapes of the conic section. Now we will look at how we can define the different shapes of conic section based on the eccentricity value. Before going to that, we should have two things. One is the straight line, which is known as the directrix, and the second one is the point, which is known as the focus. How it is possible to define a conic section shape based on the eccentricity value? Now take an example. If we have to plot the locus of a point which travels such that the distance from a fixed point is always the same, then that geometry, as we all know, is going to be a circle, because if we consider circle as a locus of a point, then that point will be having a fixed distance of a radius from the fixed point, and that fixed point is usually we call it as the center of the circle rather than we calling it as the focus. For the conic section, we will take two distances, one from the directrix and one from the focus, and based on that we can define whether it is a hyperbola or it is a parabola, something like that. And first we discuss about the parabola. Suppose we had to plot the locus of a point with the condition such that the locus should always keep a equal distance with the focus and with the directrix. So distance with the directrix means the perpendicular distance with the directrix. In that case, the geometry we are going to get is the parabola. That is, if we take a red dot on the parabola, then the distance with the directrix is a1 and the distance with the focus is b1, and a1 should be equal to b1. Now take a green dot on the parabola, then distance with the directrix is a2 and distance with the focus is b2, then a2 should be equal to b2. Then the third point, that the blue one, the distance with the directrix is a3 and the distance with the focus is b3. Now the a3 should be equal to b3. Now in some other terms, we can define some term which is known as the eccentricity, which is the topic of this video, which is the ratio between the distance from the fixed point, which is the focus, divided by distance from the fixed line, which is known as the directrix. So here the eccentricity, the common letter is small letter e, will be equal to b1 by a1, equal to b2 by a2, equal to b3 by a3, equal to 1. So that means for a parabola, the value of eccentricity is going to be equal to 1. Parabola in itself comes with a wide varieties. That is, some will be wide open, some will be narrower, but all should be having the eccentricity value equal to 1. Then how it is possible? So that is possible by varying the distance between the focus and the directrix. That is, if the distance between the focus and directrix is more, then the parabola will be wide open, and if the distance is less between the focus and directrix, then the parabola will be narrower. But in all cases, the value of the eccentricity will be equal to 1. So for the next shape, we define a condition such that the locus of the point is such that the distance from the directrix is always less than the distance from the focus. So if you going to plot such a condition with bearing a constant ratio, that keep in mind, what you are going to get is known as the hyperbola. So you can see there is a light shift to the left side. That is because the distance from the directrix is having a lesser value. So here we take the first point, red point, with the distances a1 and b1, then the green one with the distances a2 and b2, then the third one with the distances a3 and b3. So if we find the value of the eccentricity, that is equal to b1 by a1, equal to b2 by a2, and which is equal to b3 by a3, and that value is going to be greater than 1, and that figure is known as the hyperbola. So here we can write for hyperbola, value of eccentricity is greater than 1. Now consider the third case, which is opposite to the previous one. That is, the distance from the directrix is always greater than the distance from the focus. So in that case, what you are going to obtain is something known as the ellipse. So for the ellipse, if we take the first point, red one, the distances are a1 and b1, and the green one, the distances are a2 and b2, and the blue one, the distance from the directrix is a3 and distance from the focus is b3. So if we find out the eccentricity value, it is going to be b1 by a1 equal to b2 by a2 equal to b3 by a3, which is less than 1. So here I am writing as, for ellipse, the value of eccentricity is going to be less than 1. So this is the explanation for the eccentricity, that is the definition for the eccentricity, and how you can distinguish the different conic shapes based on the eccentricity values. Thank you for watching.